So this is part 2 of the demonstration, and here I would like to introduce vectors in Python, not strictly in Python. This is a facility which is due to the numerical Python's library, NumPy, which is the base library to use vectors and n-dimensional arrays in Python. So I call this library. So to getting used to with its function is import numpy as np. This is the standard procedure. And the plotting library matplotlib.py plot as plt. So these libraries has been included in the program. So now I can define an array of numbers. So for example, I say numpy array. So with the parentheses, you can write whatever number you wish to include here: 1, -2, 3, 3, -4, and 5. And their indices would run from 0 to 4. So 0 will be included. So and I define y equals numpy zeros. So I say 5 zeros and zeros of type real float. This is important. If once you have initialized with only the integers, so or if by default you ask Python to assign the type of the numbers, and by seeing your integer numbers, it assigned it as the integer array. Then after that, further calculations in Python will be done in integer mode for that array. So it's very important. Therefore, follow the Fortran practice. Keep in mind that everything is implicit null, right? Right. So that's why I have very rare float. I struggled on this problem, or the problem initiated from this one very long in one of my classes. So I struggled and I failed in the class. I fell from the virtual excitement pendulum, and I was injured in one class. Therefore, morally injured in the class. Students' behavior is tricky. They always tend to injure the faculty morally from their strange faces. So now I write here for I in range 5, and so I can do the computations. I say okay, y of I in the explicit fashion, say 2 times x of I. That's it. And in the same loop, we can do the printing. So now I write a print statement. Percent 10.3f, then percent 2 no percent 10.3f, and after that I write here percent x of I and x of y of I. Let's see whether it works or not, whether I have written it correctly or not. So array indices should be written with the brackets. Okay, there is something wrong with this one. Well, I must read the. Okay, somewhere here is the problem. Okay, done. So formatting. just like Fortran style. So we can interpret the values. So that's the print statement. And this is very similar to the print statement we find in C language and in MATLAB, right? So you can now interpret the MATLAB codes as well, right? In the in the first part of today's demonstration, I showed what is the similarity, how to write for loop in MATLAB. So, and the style is same, very similar to the style we observed in the language Fortran. So 10.3F, F is for the floating point. In Fortran, it was written F10.3. And there is one percent sign seems to be a bit additional, right? So sometimes people say that these signs are unnecessary. So Fortran was loved with the Fortran is still loved with the avoidance of these unnecessary sign, percentage sign, and all that. But this is there, right? And if I would like to introduce here the I, so for I, there will be 4 4I or 4D. And here I can write I as well. So 0, 1, 2, 3, 4, right? So very, very simple. The primitive print statements. With the plot, we can do the plotting PLT, plot X and Y. And okay, I can say this one. So points will be plotted in this. This is the additive facility for which we use these programming languages. Now, if I say y equal to 3 times x, and okay, I say print x equals x and this parenthesis, right? And similarly y, simple y. Okay, so you can see the you do not require very sophisticated print statement or complete print statements to pop up your variables, right? But to keep a record, we generally write. I prefer writing y equals y. So it is the vector operation. Okay. With this y and with this y, let me test this one. NumPy dot. So the function from the Python library dot AB, the dot product of two arrays. In zero semester, we developed this function by ourselves, right? So it means you can be a part of Python uh, development libraries, right? So dot x and y. What is generally the answer of dot product? It's a single number, right? 165. Next, matrix. There are other methods to assign arrays as well. So you should see that those demonstration in my lecture. You can just have to follow those lines from the lecture. So I write here a matrix A equals numpy array So you can write. So here you have to use the separate arrays in parentheses. So it is like the uh, the combination of several one-dimensional vectors. So I write here first vector 1, 2, 3. This is first row, then the second row I use minus 1, minus 2, minus 3, okay, minus 5. And then the third array 0, 0, minus 1, and again 0. And to print it, just I write here a numpy. I have realized that there is one parenthesis missing. Not parenthesis, it is the bracket. You can see the third row, the second row, and the first row. Well, it is a good practice to always see the errors, right? So does not match opening parenthesis. Okay, this is also parenthesis. Okay, so that's the way it will be printed. And the problem for struggle. All the time you have to keep reminding yourself it's a 3 by 3 matrix. However, the indices would run from 0, 1, 2. 0, 1, 2 for the row and 0, 1, 2 for the column. But let me show you one interesting thing. If you want to see what type of variables have been selected and being used in your program, you can make a click over here. So it is A is n-dimensional array. Its shape is 3 by 3 and all the values are here, right? At times you may require the inverse of a matrix. Okay. So I write matrix B equals numpy inv of A. So inv is not there. Basically, in NumPy, there are several libraries, right? So there is one library, linear algebra. I go to NumPy library, and go to the section of special section on the linear algebra. And then in linear algebra, there are several functions. Risky decomposition, condition number, determinant, eigenvalue, eigenvalue Hermitian, eigenvalues, inverse. So the library is already there. So you can use in your program. So I write here inv. This is inverse, but how to confirm it? Confirm it, let's say, let's compute numpy dot matrix multiplication. Okay. This is in the numpy library directly. Matrix multiplication A and B. What answer do you expect? Is an identity matrix of size 3 by 3. So very nice. Computing inverse is one of the most demanding problems in the scientific computing. If you want to assign an identity matrix, you can say numpy identity matrix 5, just 5. Okay. No, it is in the linear algebra library. It is not in the linear algebra library. No, it is indirectly in the NumPy library. Okay, a 5 by 5 identity matrix. So that's the way to call and use some of the libraries, and uh, uh, and the same procedure goes with every library of Python. You have to identify the function, its arguments. The help is really great in Python. So let's stop at this point for today's demonstrations.